Hello AI worlds. In this video I will talk about LTX-Core Pipeline Architectures, how LTX pipeline works end to end. Like if you give an input prompt, video description plus audio transcripts, and how it's generating audio with video. So let's begin. LTX is a groundbreaking asymmetric dual-stream diffusion transformer that simultaneously generates synchronized video and audio content from the text. One is more important is it jointly models audio video dependency and enabling true temporal synchronization between multi-modality. Here we'll talk about 14 billion video stream, 5 billion audio stream, 48 transformer block, bidirectional cross attentions. These components how connected each other, how it's working. So let's begin with complete generation pipeline, where you will give input prompt covering video description in audio transcript and descriptions. For video context, it will create video context embedding 4096 dimensions, and for audio it will create audio context 2048 dimension embedding vector and use here gamma 3 encoder for create audio video embeddings, and that would be in space of batch size, channel, frame, height and width, and this is in the latent space. So now we want to give this input into transformer block, so we need to convert in transformer level input in sequence format, that would be batch and sequence line and dimension. So that would go to transformer block, and transformer block having a denoising step. So you know how diffusion working. If you know how stable diffusion working, then only you know this complete process. If you know how stable diffusion can generate a image using denoising process, using diffusion process, then only you are able to understand it video generations along with audio generations. So for this you can go my previous video where I explain stable diffusion step by step. Now in the stable diffusion version 1, first one that use unit for denoising finally create a image information. Similar here in this block use transformer for especially for diffusion for denoising and predict the noise and find the image informations along with frame and temporal information that would be complete the video information in the latent space. So that use of this transformer, so it will produce the noise and how it will guide each steps. So for example, you are creating first step your complete sequence, but might be that is not properly accurate, then you need to guide again to second step, so that guidance apply. So that guidance can be applied with the multiple guidance strategy that would be used for process the diffusion step by step. So one of the guiding called as a CFG and STG, channel frame guidance and spatio temporal guidance that use. So batching and that is channel informations and frame information, how it will handle that guidance by this one, and how your spatial and temporal information combining that guidance key by this spatial temporal guidance. That spatially mathematic formula uses update the latent space. And again, how many steps needed, that is the decision need to be taken. So if again need to be do process this step again and again, this denoising step, read the noise and going. So after few of step 50 or 100 200 steps, based on you how much accuracy you want, yeah, it's related to it's your workflow. So the workflow complete with the certain accuracy, and you test it your step, whatever steps work for you. If is not much complex video you are creating, then not much complex video and audio information is needed, then you can reduce your steps. But have your video have much complex features, then I think you need more steps. Finally, you will get the image video and audio information in the latent space. Not latent space, in the output of transformer, which would be batch and number, sequence and dimension. Again, you need information in the latent space that would be input of video encoder for video decoder for decode the video, and would be the output of the video. And that would be, for example, here I will show here unpatchify. So in patchifications, like spatial latent flatten to sequence format, batch, sequence length, dimension, that enable transformer processing. For unpatchify, sequence format converted back to the spatial format, batch, channel, frame, height and width, that restoring the structure that needed in the VAE decoding, right? So this VAE decoder needed finally in spatial format input. So that's why we are converting this sequence input to spatial format input for both. So video encoder, decoder taking this spatial format, and finally male spectrum generate, and that would be input of vocoder that would generate the video, audio. So this is complete end-to-end pipeline to generate the video along with audio. So now we'll go more deeper how this dual stream transformer architecture working here. So I talk about that this model can generate audio with lip syncing, with Foley. For example, if you close the door, then what sound bit would be generated? If you are standing in the river, then what sound generated by flow of the water, stream, yeah, car, whatever. So all the deeper information, Foley nature informations that you need to generate the background musics at all. So how it will sync that? If you close the door, that time only the sound should be generated. So how it will happen? So that is happen due to this dual stream transformer architecture. So in dual stream transformer architecture is, for example, RMS norm, then self attention, and then cross attention, and then audio video cross attention with 1D ROP. So ROP means rotational positional encoding here used with the temporal informations. So this block is very important here, audio video cross attention. So if you know cross attention, then only you will understand here, but simple context I will give what is the cross attention. So if you have multimodality, then input would be a input would be a frame, spatial information, yeah, text embedding, whatever. So for example, in transformer block, you have in the attentions, you have Q query, key and value. So query would be your image information and value would be, or your value and key would be a text, the two modality. And again you vice versa also, you need audio information also, the audio would be the query and value would be the text, whatever you are getting. So and you change it, so that's why the cross attention applied here, video to audio one, second is audio attend to video, and vice versa, video attend to audio. So this is here called as a bidirectional attention mechanism here. So this helps to lip syncing and foreign music generations. So especially this bidirectional audio video cross attention with one dimension ROP means rotational positional embedding. Rotational positioning embedding means you have informations about each frame and time for what information is there. So like if you're creating embedding and token, right, that time the positional embedding very important, but rotational positional embedding is important for especially where you need sync the information. So it enables subframe temporal alignment. Subframes mean here, for example, you have 25 fps, then in 40 millisecond you are generating a one frame, correct? So each frame should be sync with the audio signal. So for example, in one frame, what lip is open, yeah, closed. If lip is closed, that time phonemes should be generating, and whenever lip open, that time phonemes should be applied, right? So that frame sequence, subframe sequence also mapped, so that ensuring the lip syncing accuracy and natural foley generation without required text to video and video to add audio pipeline. So this pipeline previously people use for that, but this is also very costly. But now I think this is used using this 1D temporal ROP with bidirectional audio video cross attention help to generate audio with the lip syncing accuracy. So this about architectures. I explained all these components also. So I just repeat what are the core components. So video VAE decoder, encoder. So encoder compress batch 3 channel frame height and width to this, it will encode in this information. Again decoder and decode this information to pixel space. So compression would be like 182 in spatial information 132. Similar to audio VAE, vocoder finally generate your spectrum. Gamma text encoder for create your embedding vectors. Diffusion component, so we here diffusion components especially use scheduler, LTX2 scheduler, linear quadratic scheduler, CFZ, STZ, spatial temporal, APZ, and noisers, upscaler. So upscaler used for if you want to scale your output resolution. So for multi-stage pipeline it's used this upscaler, right? Okay, so now I will talk about key feature. So we already discussed the key feature is dual stream design. So this is the dual stream design. This is the very important. The dual stream design help you to synchronize audio and video, and finally in the one single pipeline you can generate audio and video both, right? So that is the key feature. So a symmetric dual stream design. 14 billion video stream capture spatial temporal dynamic with 3D rotational positional encoding, while 5 billion audio stream process one dimensional temporal sequence. That is very important. And both share 48 transformer block. So, and both are optimized. And another is key feature is bidirectional cross attention that I already talked. And this is very important. So now like you can generate fast video also with the quantization, so it will provide quantization support. And that cross modality, multi-layer features, fine-grained control for control video. So these are core features to LTX pipeline. So what is the technical stack? PyTorch, Transformer, Diffuser, Gamma 3, ROP, VAE, Hygiene, Ceph, tensors, and quantizations and LoRa fusions. So these are model specifications. And other thing also we'll talk about later, how the two-stage pipeline working, how IC LoRa working, how digital pipeline working, keyframe interpolations. That is more important features. Then you can control with your what you want to create a video with your conditional input. Conditional means, okay, I want this person that given an image, which frame you want to edit it. So all the conditional it will take and create a video with for you. So this is all about this LTX-Core Pipeline. So if you like this video, thank you so much. If you want more about information deeper any blog, please comment. Thank you so much.